will solve your problem. Will solve your problem also, whatever the problem there in your book, and the previous year problem also will solve. So,
Okay, sir.
so that is first one. Let us try to understand limitation. Okay, limitation of first law of thermodynamics. First law of
Yes, sir.
thermodynamics. This is what.
Thermodynamics.
Hmm. So if you talk about first law of thermodynamics, so what the first law of thermodynamics they are saying, that is delta U is equal to, okay, Q plus W. This was the first law of thermodynamics mathematical expression, that whatever the heat if you are supplying, so some amount of heat is being used to increase the internal energy and another part is used to do the work. This was the first law of thermodynamics. Now the what the point is, important point which we have to understand is that it is having some of the limitation. What the limitation? That this law never said that is what is the direction. Okay, so that is first
Yes, sir.
limitation is this law. Okay, let me write down this one. Okay, this law did not explain the direction of reaction. That is what direction of reaction. How much work is done, that is okay. This is very easily it was explaining. How much internal energy is being changed, that is also being explained. But when you are talking about that is, you know, which direction the reaction will proceed, it does not say. So this is the first drawback of the first law of
Yes,
thermodynamics.
sir.
And second point also, that is this law, this law did not explain, this law did not explain what it is not explaining, that this not explain that which process is, which process is, they are saying which process is, they are saying which process is
Yes, sir.
feasible, no, feasible and which is not. So any process is feasible or not feasible, that is
Yes,
taking
sir.
place or not, that this law never said. Third one, they are saying this law, if you talk about this law, could not explain, this law could not explain the spontaneity of reaction, spontaneity or disorder of reaction. Because if you are heating, that is the system is going to be disorder. If you are heating anything, the system is going to be disorder. But this law is not explaining anything that which process will be spontaneous, means that is the spontaneous means randomness, you can say disorder, and which process will be order, right? So this law,
Yes, sir.
that is why this law failed. So one point you need to please keep in mind, this law do not explain the direction of reaction. This is the very much important, because this ask in the NEET exam. This law do not explain the order of reaction. Okay, which process is feasible,
Yes,
is
sir.
not going to explain at all. Okay, and spontaneity also not going to explain. Now little bit you see, can I make the next page?
Yes, sir.
Okay. First of all, let us see that one. What is the, okay? Now we are going to understand with the help of second law of thermodynamics that what is meaning of, how can we understand the direction of reaction. So direct second law of thermodynamics, here is second law of thermodynamics. Okay,
Yes, sir.
thermodynamics. Second law of thermodynamics. If you go the previous page, what they are saying, this law did not explain, this law did not explain the direction of reaction, but here it is going to explain. What they are saying, that if two ways are there, two ways are there, in terms of, little bit I'm explaining, in terms of entropy. Okay, in terms of
Yes, sir.
entropy. Okay, and that is in terms of, if you talk about in terms of gives free energy, gives free energy. This is the two way. You might have studied in the somewhere gives free energy. We study in the equilibrium chapter also. So here is
Yes, sir.
saying if delta G naught, if delta G naught is negative, so the process is spontaneous. Spontaneous means that is the process taking place itself. You need not to do anything. It will be taking place by its own. If suppose another thing is there, delta G is equal to positive, non-spontaneous. Not spontaneous means that is you need to do work to know do the if the delta G is positive, you need to do the work. But if delta G is negative, you need not to do anything. Similarly, you talk about the entropy. If delta S is equal to it is coming negative, so that is it is also going to be spontaneous. This is going to be spontaneous. Okay, delta
Yes, sir.
S is going to be positive. That is also going to be non-spontaneous. This is the non-spontaneous. Now, spont uh, spontaneity I'm explaining in the next page. If delta S is equal to 0, so delta S is equal to 0 means it is going to be equilibrium. And here also you study here in the equilibrium, delta G naught is equal to 0. It is explaining the equilibrium. Equilibrium.
Yes,
So
sir.
the second law of thermodynamics is all about that is the reaction going to be the forward or reverse. What will be the direction of reaction? What will be that is it will be the spontaneous taking place. Spontaneous means it is very much taking place. Non-spontaneous means it is not going to take place at all. You need to do the so much of work to let the reaction happen. So what I'm going to do, I'm going to explain the second law of thermodynamics. I'm explaining in the next class. Okay, definition. Definition of second law of thermodynamics. So when you talk about the definition, what this law is saying, it state, it state that any spontaneous occurring process, spontaneous occurring process
Process.
will always lead to an increase in increase in entropy of the system. Now let
Yes,
me
sir.
try to explain that is entropy. It is quite confusing to you. Entropy. Entropy means disorderness of system. Disorderness of system. Disorderness of system. Of disorderness of system means suppose at low temperature something are there solid. Okay, so if the temperature is low is there, so the solid is there. This is solid. So solid is having the fixed shape, yes or no? This is fixed shape. The fixed shape is there means it is order. Particles are there in the solid at low temperature. They are having the this is the order form, yes or no? Because shape is fixed means it's order. What you are going to do? Heat. So if you are heating, this is going to be what in the gaseous form, yes or no?
Yes, sir.
So if you are heating, so it is going to be gaseous form. Suppose it is the sodium chloride crystal is there, NaCl. So ClNa. So what will be there in the water? If you are heating in the water, heat in water. So Na will be here, Cl will be here, Na will be here, Cl will be here. Okay. Then here is the Na plus, Cl minus. Getting my point. So which one is the order one? Which one is the fixed order is there, particular shape is there? The first one or the second one? This is first one. This is the
First one.
so order, and this is what is disorder. Okay. So disorder means what? Janab, if we talk about disorder, entropy means disorderness of the system or randomness of system. Okay, this is also called randomness of what system? Are you able to understand?
Yes, sir.
Okay, so that is first of all. Now the again let us try to understand the definition. Let's attack again on the definition. What the definition is saying. Okay. Mhm. It is little bit. Okay. Ah. So it state that any spontaneous occurring process, spontaneous occurring process means the process it is taking place itself. How you can be able to know? If the entropy is negative, it will be taking itself. So always leads to an increase in entropy. So if any spontaneous like that is two gases, if you are mixing, two gases if you are mixing, so that will become more randomized. It is going to more randomized, means entropy increasing. If you are increasing the temperature, gas molecule become, that is liquid molecule become more randomized in the vapor state. So that is they are saying that is spontaneous process, or that is entropy increases. Okay. So the point entropy here is the disorderness of system. Keep in mind entropy means disorderness of system. Here I explained you. Can I change the page?
Yes, sir.
Okay, so let me try to write the again entropy definition. Entropy. This is the S. Okay, it is measure of, little bit definition I changed. Let me. It is measure of randomness, randomness or disorder or disorder of the disorder of the molecules of system, molecules of system, molecules of system. Okay, so this is what. So what is the formula mathematically? It is defined as, how you are going to define this. So mathematical form, that is too many numericals are there. Delta S is equal to Q reversible upon T. That is the first one. Q reversible, if you talk about Q reversible. So Q reversible means heat given to system. Heat given to system. Okay, this one. Temperature T. Temperature in Kelvin. This is what going to be temperature in Kelvin. This is delta S is equal to change in entropy. Change in entropy. So these are the 3 points are there that first of all we need to write. Can you please make a note of it?
Yes, sir.
One more definition is there that also we need to write. Not working at all. If delta S sublimation is there, so that is here is delta H. This is vaporization. Minus here is temperature. So entropy of sublimation, how we calculate entropy of sublimation? Entropy of vaporization, Vaporization. Entropy of vaporization. So these are the terms we have to keep in mind. This is the formula number 1. This is formula number 2. Formula number 3 is what? Delta S total. Delta S total is equal to delta S system Okay, delta S system plus delta S surrounding. Here is that is going to be this one. So total three rules are there that we have to keep in mind. First one, what is there? Okay, delta S is equal to Q reversible upon temperature. This is the first one. If you are talking about the second one, delta S sublimation means delta H vaporization upon temperature. Delta S total is equal to delta S system plus delta S surrounding. So this is all about the points. Okay, so what we are going to do,
Yes, sir.
we are going to solve some of the problem to understand this in the details. So let's try to understand this one. Question number one. Latent, here they use the latent heat of fusion. Heat of fusion. Heat of fusion means heat given. Heat of fusion means heat given. Okay, that you keep in mind. Of ice is 6 kilojoule per mole. Okay, calculate the entropy change in the fusion of ice. Calculate,
Yes, sir.
calculate entropy change in the fusion of ice. Change in the fusion of ice. Fusion of ice. Okay. Up now, let's try to understand solution. Okay, how can you? So here you see delta H, delta Q they have given heat of fusion. So what is Q is given? How much? 6 kilojoule per mole. Okay. Calculate the entropy change in the fusion. Up now ice is there. Okay. And if you are fusing this one, so what the temperature will be there? 0 degrees Celsius. At 0 degrees Celsius now, temperature is 0 degrees Celsius. It is going to fuse to what? That can be the in the liquid form. So that is what temperature? The ice is present at temperature 0 degree. Okay. 0 degree means ice. 100 degree means vapor. Between 0 to 1, that is liquid. So T is equal to, they have given 0 degrees Celsius. If you want to convert in Kelvin, if you want to convert in Kelvin, so what we are going to do, 0 degrees Celsius plus 273 Kelvin. So it will be like that. So Celsius will be out. So what the point it is coming? How much it is going to? 0 plus 273. So it is coming 273 Kelvin. Now that is the delta S they are asking. Delta S is equal to Q by T. So simply you can write that is 6 upon, you can write 273. Now it is kilojoule is there. If you are converting into joule, so it is going to be 6000 joule per mole. Okay. So better you can put out the in the joule per mole. So how much is going to come? You can divide it out. It is coming 21.98 joule. Okay, this is the joule per mole is there. So it is the joule per mole, and here is Kelvin. So it is going to be joule per mole and per Kelvin. Can you please understand this one, or is still
Yes, sir.
problem is there? Is it okay?
Yes, sir.
Okay. So this is the problem based on the first rule. Okay. We are going for the, this is the first rule now. Let us try to solve one more problem based on it. Can I erase?
Yes.
Okay. I'll change the this PDF also. I'll take the pic and I'll send to you. Okay. I'll
Okay, sir.
now the next question. Tomorrow I'll finish this one, the theory portion. Tomorrow I'll teach the Gibbs free energy. Then 1 2 days I'll go for the numerical problem. And then you suggest me that what chapter you want. But 1 2 days I'll teach you the numericals one. That is previous year problem.
Yeah.
Hmm.
Sir,
Uh,
sir, can you end the class by 8?
Today.
Yes, sir. Cause sir, I have one more exam tomorrow.
Oh, so
Tomorrow
time.
I have my next exam. We can test.
Okay, okay, no problem. So can we
Yes,
study
sir.
10 minutes more?
Yes, sir. 10 minutes, 8. You can end.
Okay, 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 sure.
Mm,
So,
thank you, sir.
okay, no
Sir,
problem.
today only, sir.
No problem. Okay, in any other day we can study more. So here,
Yes, sir.
it is hanging, the system here also hanging. I don't know what happened to this one. Pen. It started. One more question I am writing. What the question is? The enthalpy change. Yeah, we are writing the heat change for transition, the heat change for transition of liquid water to steam. It is changing to steam is how much? 40.8 kilojoule per mole. This much is there at 737 Kelvin. Calculate, they are saying calculate delta S for the process. Delta S for the process. This they are asking. So how can you be able to do this problem? Okay. They are saying the heat change for the transition of liquid water. So that is H2O is there. This is liquid is there. And this is converting. They are to steam. Here that is H2O. They are talking about steam. But here temperature they have mentioned 737 Kelvin. Okay. So temperature they have given how much? 737 Kelvin. Heat they have given how much? They have given 40.8 kilojoule per mole. If you are talking about in joule, so that is 40.8 is there multiplied by 1000 joule per mole, or you can write that is 40800 joule per mole. So what we have to write, we have to calculate delta S. Delta S is equal to Q upon T. So Q value is how much is there? 40800. Okay, 40800 divided by temperature 737 Kelvin. Here is joule per mole. So here you, if you solve this one, how much is going to come? Temperature. Temperature is little bit, it's wrong. It is 337, I think, because the steam is converting into 100 degree now. So this question is something, no, 337 only, not 737. Steam means 337. This is. So here you kindly rechange. Here is 337. So if you are talking about this is going to come, how much is coming? 109.38 joule, Kelvin inverse and mole inverse.
Yes, sir.
Okay. So this way the problem is there. What I am going to do, we are going to solve some more two more problem. Let me. Anything is there? I'm searching. Okay. That is, I am taking the second formula. What are the second formula is there? This one, delta S sublimation is equal to vaporization upon temperature. So let us try to solve the problem based on it. Okay. So what the problem? Yeah, I got the problem. Question is there. This yes. So on the basis of third formula, we'll be studying in the next class. They are saying the standard enthalpy of vaporization is standard enthalpy of vaporization. Enthalpy of vaporization. The standard enthalpy of vaporization per mole for ethanol. Per mole for ethanol is, okay, enthalpy of vaporization is full stop if delta S is 109.8 joule Kelvin inverse mole inverse at boiling point. At boiling point, they are saying how much boiling point they are saying 78.5 degrees Celsius. Okay, but you need to take in the Kelvin only here. So little bit it is tricky one. So they are asking delta H naught, and what they are saying vaporization VAP. They are asking what is their delta S naught. Here is not. They have given how much they have given, that is sublimation they have given enthalpy. How much is given here? If you see 109.8. Next one, temperature they have given 78.5. You have to convert into Kelvin. 78.5 plus 273. So it is going to come 351.5 Kelvin. Now you can calculate very easily. Delta S sublimation is equal to delta H vaporization upon temperature. Temperature means boiling point, TB. So delta H, they are asking vaporization. So what we can, delta S sublimation multiply by TB. So delta S sublimation, how much is there? 109.8 into TB. How much is there? 351.5. So how much it is going to come? It's going to come, we can multiply with this one. It is coming
Yes, sir.
38585. It is joule per mole. It is coming. If you want to kilojoule per mole, you can divide by 1000. So it is coming 38.585. It is kilojoule
Yes, sir.
per mole. So this is based on the problem number 2. Uh, so one more formula is there. Two more formula is there. Reversible is also there, that we will study in because tomorrow you are having exam, so you can study for your exam.
Yes, sir.
So we'll be studying, that is tomorrow, remaining concept. So tomorrow it will take in that is entropy only. And next one class will be Gibbs free energy. Then chapter will be over.
Yes,
Which
sir.
chapter you want more? You want any other chapter from the 11th?
Sir, I'll tell you tomorrow.
Okay, no problem. Okay. So can we stop today?
Yes, sir.
Okay,
Sir,
okay.
can you just share me the notes for this, please?
Hi, I'll share. Uh,
Okay,
okay,
thank you, sir.
I'll take the peek and I'll complete. Surely I'll share.
Okay.
Okay. Bye.
Thank you, sir. Bye.
Mhm. ऐसे तो